Multiple IPAM in Cilium CNI. Before getting to details, let's understand the base principles of Kubernetes behavior. In Kubernetes cluster, you have to define so-called pod CIDR, typically at the cluster initialization. For example, 10/000/16 with the mask 24. Every node in the cluster, in this example, will get /24 out of the subnet. For example, node 1 will get 10.0.1/24, node 2 10.0.2/24, and so on. The second rule is that when the pod is scheduled to run on a given node, the pod IP address belongs to the node pod subnet. When the pod is evicted from the node, when the node location changes, the pod location changes, then the pod IP address will also change. Cilium CNI extends the Kubernetes IPAM behavior. It of course supports the Kubernetes IPAM, but also supports what's called the cluster IPAM as well as multiple IPAM. This table highlights the main differences between these different IPAM modes. We also have the link to get more details. What is important to highlight here is that multiple IPAM is the only IPAM for on-premise Kubernetes clusters that supports multiple CIDRs per node and supports dynamic CIDR IP allocation. And that's indeed the unique characteristics of multiple IPAM, because you can allocate pod CIDRs from multiple different IPAM pools, and then you can selectively configure using annotation which pool will be used to give an IP address to the pod workload KubeVirt VM. Multiple IPAM mode in Cilium has some requirements. They are quite well documented. On the left you have the screenshot of these requirements, and on the right you have the example of Helm chart values that defines multiple IPAM as well as the associated settings. What I also want to highlight here is that the multiple section of Helm values contains the default pool definition, which is something that behaves like a standard Kubernetes pod CIDR. So it's cluster-wide, it's associated, so every node in the cluster will get a subnet from this pool. Once your cluster is initialized and up and running, you can define at runtime the extra non-default pools. You can define as many as you wish, with the only rule that you should make sure there is no overlap between the subnets defined in different Cilium pod IP pools CRDs. You will also see that this object, you can always get this object using kubectl command line, but this object has no status, so it only will show you the definition of the pool. So how to track the allocation? You will use a Cilium node CRD for that. Cilium node objects are defined per cluster node, similarly to Kubernetes node object. And then inside the Cilium node CRD objects, you will have the IPAM section that shows you what are the requests for different pools, as well as what are the allocations. And if you start with vanilla Kubernetes cluster, you should expect to see the default pool cluster requests and allocations on every Cilium node object. Annotation is used to control which pool will be used for pod IP allocation. So that annotation can be defined on the namespace level or on the pod level, and the pod level annotation takes precedence. If there is no annotation at the namespace or pod level, then the pod will be allocated with IP from the default pool. Suppose you have a vanilla cluster and you just create 2 extra pools. On the left you have the definitions of these pools, pool 1 and pool 2. Once you do that, you should not expect any change yet at the Cilium node level, at the requests and allocations level, because there is no one is requesting an allocation from this pool. There is no pod, no workload, which is annotated with the pool 1 or pool 2. In this example, let's say I have a pool 1 defined, it's /28, and it's configured with mask size 29, which means I can have two different subnets out of this pool. And I have one deployment, single replica, which is annotated with that pool. It references pool 1. When that deployment is created, when Kubernetes scheduler makes a decision that the pod, which is backed by this deployment, is running on node kind worker, then the kind worker will request a subnet out of the pool 1. It will get that subnet from Cilium operator, and then it will lease one IP address from this pool for the pod. On the right, you have the reference of Cilium node kind worker 2 state, which shows no reference to pool 1 because the single pool 1 client pod is deployed on kind worker node. It confirms that the pools are allocated dynamically and where needed. Refer to these isovariant Cilium links for further details.